Next chapter, volume and capacity. Volume is the amount of space occupied by a solid in 3D. Prisms are solids with uniform cross-sections. This is a triangular prism. It has two identical faces parallel to each other. If we were to cut this solid parallel to these faces, we will see that the cross-sections obtained will be exactly like the two identical faces. This is a different prism. The cross-section now is a pentagon. A cylinder has a uniform circular cross-section. It is a circular prism. A pyramid is not a prism because the area of the cross-section reduces progressively upwards. A cone is similar to a pyramid except that it has a circular base. It is not a prism either. The general formula for finding the volumes of prism is volume is equal to cross-section area times length. For this triangular prism, the cross-section is a triangle, and so volume is equal to the area of the triangle times the length. Area of the triangle is equal to a half base times height. This is equal to a half times 9 times 10, and then we multiply by 11 to get volume, and so volume is equal to 495 cubic centimeters. This is also a prism because it has a uniform cross-section. In this case, it is a trapezium. And so volume is equal to the area of the trapezium times length. A half times 9 plus 13 times 10, and then we multiply by 8. For a cylinder, the cross-section is a circle. In this case, the length will be the height. Volume is equal to area times height, that is pi r squared times height. Let's take an example. The cylinder is made up of a material 1 centimeter thick. The internal diameter is 12 centimeters and the height is 22 centimeters. If the cylinder is open at the top, calculate the volume of the material used to make it. The solution: to find the volume of the material, we find the entire volume and subtract the internal volume. We start with the external volume. If the material is 1 centimeter thick, then the external diameter is equal to 12 plus 1 plus 1, and that gives us 14 centimeters. Volume is pi r squared times height. That is 22 over 7 times 7 times 7 times 22, which gives us 3,388 cubic centimeters. Internal volume. When calculating the internal volume, you must bear in mind that the thickness of the material includes the base as well. And so the internal height is 22 centimeters minus 1, which gives us 21 centimeters. Volume will be equal to 22 over 7 times 6 times 6 times 21, and that gives us 2,376. Volume of the material is equal to 3,388 minus 2,376, and that gives us 1,012 centimeter cubed. And now we look at converting units of volume. Now the units of volume are cubic millimeters, cubic centimeters, cubic meters, and cubic kilometers. But the most common ones are cubic centimeters and cubic meters. Interconverting these units is quite easy, for as long as we know the relationships between the centimeters and meters. We know that 1 meter is equivalent to 100 centimeters, and that 1 cubic meter means 1 meter times 1 meter times 1 meter, which is 100 centimeters times 100 centimeters times 100 centimeters, and that gives us 1,000,000 cubic centimeters. And therefore, 1 cubic meter is equivalent to 1,000,000 cubic centimeters. With this relationship, it really should be easy to interconvert between the two units. For example, convert 3.2 cubic meters to centimeter cube. We say that 1 cubic meter is equal to 1,000,000 cubic centimeters. How about 3.2 cubic meters? So we have 3.2 cubic meters over 1 cubic meter times 1,000,000 cubic centimeters. The cubic meters cancel out, and that gives us 3,200,000 cubic centimeters. Another example, convert 40,500 cubic centimeters into cubic meters. Again, we say 1 cubic meter is equivalent to 1,000,000 cubic centimeters. How about 40,500 cubic centimeters? We have 1 cubic meter times 40,500 cubic centimeters over 1,000,000 cubic centimeters. The cubic centimeters cancel out, and we have 0.0405 cubic meters. Now, when working the volume of a real solid, you can work the volume with the given units and convert the answer, or first convert the units of length and work with them. For example, find the volume of the solid in cubic meters. The first method, we first find the volume in cubic centimeters. That is 40 times 30 times 60, which gives us 72,000 cubic centimeters. And now we convert the cubic centimeters to cubic meters. 1 cubic meter is equivalent to 1,000,000 cubic centimeters. How about 72,000 cubic centimeters? We have 1 cubic meter times 72,000 cubic centimeters over 1,000,000 cubic centimeters. Cubic centimeters cancel out, and we remain with 0.072 cubic meters. Alternatively, we could convert the lengths into meters first. We know that 1 meter is equivalent to 100 centimeters. And so we have 40 over 100 is equivalent to 0.4 meters. 30 over 100 is equal to 0.3 meters. And 60 over 100 is equal to 0.6 meters. And so volume is equal to 0.4 times 0.3 times 0.6, which gives us the same answer, 0.072 cubic centimeters. And now we move to capacity. Capacity basically refers to the amount of liquid that can be accommodated by a container. Capacity is measured in liters together with its subunits. The common units are milliliters and liters. When we know the volume of a solid, we can calculate the capacity using the following relationships. A volume of 1 cubic centimeters will have a capacity of 1 milliliter. A volume of 1,000 cubic centimeters will have a capacity of 1 liter. A volume of 1 cubic decimeter will also have a capacity of 1 liter, and that is because 1 cubic decimeter is equal to 1,000 cubic centimeters. Lastly, a volume of 1 cubic meter will hold a capacity of 1,000 liters. Let's take an example. A rectangular tank measures 2 meters by 3 meters by 4 meters. Calculate the amount of water it can hold when half full. We calculate volume first. The total volume is 2 times 3 times 4, which is 24 cubic meters. Half of that volume is a half times 24, which gives us 12 cubic meters. Now we get the capacity. 1 cubic meter is equivalent to 1,000 liters. How about 12 cubic meters? We have 12 cubic meters times 1,000 liters over 1 cubic meter. The cubic meters cancel out and we remain with 12,000 liters. Suppose now the water is transferred to a cylindrical tank with a radius of 1.4 meters. How high will the water rise? So 12,000 liters of water is transferred to a cylindrical tank 1.4 meters in radius. We need to find the volume that the water will take in the tank. Actually, we know the volume of the water. We first convert the liters into cubic meters. 1 cubic meter is equal to 1,000 liters. How about 12,000 liters? We have 1 cubic meter times 12,000 liters over 1,000 liters. The liters cancel out and we remain with 12 cubic meters. This is the volume the water will need in the cylindrical tank. So up to what height will the water rise? Volume of a cylinder is given by pi r squared times height. So we have 22/7 times 1.4 squared times h should give us 12 cubic meters. If we cancel that out, we shall remain with 6.16 times h is equal to 12 cubic meters. So to get h, we divide both sides by 6.16 and that should give us 1.95 meters. That is the height of the water in the tank. And so the key thing is to remember how to interconvert volume and capacity.
The second thing I love about math is it's a puzzle solving kind of, if I can figure it out, and the joy of figuring it out, the kind of sense of accomplishment, the sense of excitement when you get it, the challenge of trying to get it. It's that puzzle solving kind of thing that I really like.